Hello guys, in this video we'll talk about reference and borrowing in Rust programming language. Now before we start to proceed, we have to discuss about ownership in Rust basically because this topic is very much connected to reference and borrowing. Now ownership plays very important role when we talk about memory safety in programming language. For suppose what is ownership is when I say let a is equals to 5, so let a is equals to 6. So basically a is the owner of 6. Okay, a has all the ownership of data value 6. Now either a can change 6, modify 6, it's up to a because a has the ownership of 6. Okay, now ownership and risk can be passed through various ways. Okay, now how ownership is passed, we have to first discuss about how data is stored in memory. Now in programming language we have basically two types. First is stack and the second one is heap. Some data is stored in stack memory and some data is stored in heap memory. Okay, now let's discuss some two type of string. For suppose I say that fn9 and I say that let a is equals to 5, let a is equals to hello, and let a is equals to 5.6. Now these three data types, number one is integer, second one is string literal data type, and third one is floating point. These all data types, character as well, they all are stored in stack. Okay, now what is the property of stack data type, stack memory, that the when we try to write, like when we write let a is equals to b, and for suppose let b is equals to a. Okay, now the data that is stored in stack is always copied to other variable when we write like this. Okay, let b is equals to a, so the data in a is always getting copied to b. Okay, because the data is stored in a stack. But in case of heap, the data where in the data which is stored in heap, and when we write let b is equals to a, and if a is stored in heap memory, so data is actually moved, not copied. Now which data is stored in heap? A data type called string type data type. Let a is equals to string from hello. Okay, now this is very much different from what we read written in that string literal data type. Okay, so this one let a is equals to hello. This okay, this is string literal data type. This is stored in stack and it is always copied. Okay, but this one is let a is equals to string from hello. This is actually a string type data type, and this is stored in heap data. And heap data is always move. When we write here let a is equals to b, so the data from let b is equals to a, so the data from a is actually moved to b. Now what this move means? Actually, move means the ownership of a is getting passed to b. Okay, basically we are moving the ownership of a to b. Now a is no longer owner of this data value hello. Okay, now if we try to print this function, if we try to print this variable. Okay, so if we try to print this variable a, so we will hopefully get error. So error says value borrowed here after move. Basically we have borrowed a to print hello, because but this a is actually moved. The data value is actually moved to b. Okay, when we write like b is equals to a and the data in a is stored in heap, so the data is actually moved to b. So a has no longer a right to represent hello because the data value from a has been dropped. Okay, so a become no longer invalid. Now how ownership playing important role of memory safety over here is when something have no some variable have no data value hold in it, but it is actually occupying some space in memory. Okay, so it has to be removed. Okay, because it is occupying some memory, but it is not holding any data. As the data value a has been dropped because data has been moved to b, but a is still occupying space in memory. Okay, it has been allocated in memory, so it has to be removed. So over here Rust automatically automatically makes this variable invalid. Okay, next. So it will make the a variable invalid. Okay, a will no longer be used to print this hello. Okay, so how reference works here, how to use this a after we have moved the data from a to b. Now if we want to print this a, we have to use the reference. Now, how to use reference? We have to simply add the ampersand sign over here. This ampersand sign means we actually allow b to refer some value of a. Okay, b is equal to ampersand sign a means that we allow b to use some value or use the borrow the value of a. We are actually borrowing hello from a by using this reference sign, that is ampersand sign. Now when we try to run this program, so hello has been printed because we have used the ampersand sign over here. Now here how it's working, we have to check this in this photo. See this photo. Now S1 is actually pointing to the data which is stored in heap, that is hello. And when we write it, let S is equals to S1, so the pointer of S will only follow the pointer of S1. Okay, the S will not follow the data. The data will not be moved to S. Only the pointer will be followed. S will only follow the pointer of S1. And S1 is actually uh, holding the data hello. So this is how reference works. Okay, now this was the one way in which ownership is passed when we write let b is equals to a. Another way in which ownership is passed when we write first suppose I create a user defined function. Okay, so this user defined function will take some parameter. Okay, it will take a string parameter. Okay, it will take a string parameter and it will simply print whatever the variable as a parameter it gets. So it will simply print that variable, and in the main function I will initialize a string variable, that is string type variable, that let b is equals to string from, and over here I say hello. Okay, and I will simply pass this variable to the function check. So I will simply call check function and I will pass b. Okay, so I have pass function. So when we run this program, okay, let's run this program. Simply hello will be printed. Okay, so hello has been printed. Now what if we want to print this again? What if we want to print this b variable again? Okay, so I have written println b again. So here's the error on line number 9, that is value borrowed here after move. We have borrowed the value of b to print it after moving it to check function. So basically when we pass a variable to a parameter as a parameter to a function, we are actually passing its ownership to the function. Okay, so b will be no longer holding this value hello any because it has moved its ownership to check function. Okay, so basically when we pass the variable as a parameter to a function, we actually move its data from the variable to the function. So this b will be no longer valid, it will become invalid automatically by rust make it invalid because it as it is not holding any data value, so it has to be removed to ensure memory safety. So that's why we cannot use print function to print hello by using b, because the error is value borrowed here after me. Okay, so what we have to do here to print this b value? Okay, we have to again use the reference. Okay, we have to simply add the ampersand sign over here. I will tell you what does it mean. And over here, now these two ampersand sign, this ampersand sign means borrowing. What does it is borrowing? It is actually borrowing the value from b. Whatever the uh, whatever the variable we pass as a parameter, it will borrow its data as a string. Okay, we are using ampersand sign, so over here, over the definition of check function, we are borrowing some data value, and over here this ampersand sign shows that we refers, okay, we refers some of the value of b by using this ampersand sign. Now we try to save this program, and when we will run it, so basically another hello has been printed, which is this one. So by using this ampersand sign, we will be able to use this print function again. Now look, we are actually borrowing data from b. Okay, this check function is actually borrowing data value from b. So what if I write here, okay, I have borrowed, I have passed b to check function, so I have actually borrowed some data value from b, and after that I am using b dot push str, and over here I write word. So basically I am modifying the value which I have borrowed from b. Got it? I have borrowed there over here by using ampersand sign, and after that I am using this push str function, which means uh, concatenate some string to the previous string. So we are basically concatenating world with hello. So we are modifying a borrowed value. Look if it's work or not. So here's the error, that is consider changing this to be mutable, cannot borrow as mutable. Now this function, now the main concept here is reference by default are immutable. You cannot change the data value which is taken as a reference, or which is we have taken as a borrow from other variable, okay, which we have borrowed from other variable. We have borrowed hello from b, okay, and after that we are pushing some string, or we are concatenating some string to it, so we cannot use do that, okay, because it is by default immutable. Reference are by default immutable. We have to make them mutable to, we can make them mutable to change its data value. Now how to make them mutable? You have to simply add here ampersand sign mutable keyword, okay, and you have to simply, sorry, you have to use here also, let me b is equals to, you have to simply run this program. Okay, we have not printed this, so we will print this b value. So see, hello world hello, that is this println a, and hello world as well has been printed. So we are able to concatenate world, we are able to modify the value that has been borrowed by the check function, because we have used the mute keyword. So mute actually makes this reference mutable. By default the references are immutable. Okay, so we have basically discussed about how references are used, how the data value has been borrowed by functions, and how to use mutable keyword to concatenate other strings or modify the string. So thank you very much. In the next video we'll talk about structure in Rust programming language. Thank you.